In the ever-evolving world of web development, architectural patterns play a crucial role in building scalable and maintainable applications. One such pattern gaining significant traction is micro-frontends. Micro-frontends represent a paradigm shift in front-end development, moving away from monolithic structures towards a more modular and decentralized approach. Instead of building a single large front-end application, micro-frontends advocate for breaking down the user interface into smaller, independent components. These components, known as micro-frontends, are self-contained units of functionality. They can be developed, tested, deployed, and maintained independently. Each micro-frontend focuses on a specific business domain or functionality, fostering team autonomy and accelerating development cycles. This architectural shift offers numerous advantages, particularly for large and complex web applications. By decomposing the front end into smaller, manageable pieces, micro-frontends address many challenges inherent in traditional monolithic front ends. They promote team independence, technology diversity, and faster development cycles. However, this approach also presents unique challenges, integrating independently developed components, ensuring a cohesive user experience, and managing the complexity of multiple teams and deployments require careful consideration. Understanding these advantages and drawbacks is crucial when evaluating micro-frontends as a viable architectural solution for your web development projects. Please like and share this video and subscribe to our channel. Micro-frontends offer numerous advantages that make them a compelling choice for modern web development. One significant benefit is increased development speed and agility. As teams work on independent components, they can develop, test, and deploy features without impacting other parts of the application. This autonomy allows for faster iteration cycles and quicker time to market. Another key advantage is improved scalability and maintainability. With smaller, self-contained code bases, it's easier to understand, modify, and scale individual components without affecting the entire application. This modularity reduces the risk of introducing bugs during updates and simplifies maintenance tasks. Technology diversity is another benefit. Micro-frontends allow teams to choose the best technology stack for their specific component, rather than being locked into a single framework or library for the entire application. This flexibility empowers teams to leverage the most suitable tools for the job, potentially improving performance and developer productivity. Furthermore, micro-frontends enhance fault isolation. If one component experiences issues, it doesn't necessarily bring down the entire application. Other components can continue to function independently, providing a more resilient user experience. This isolation also simplifies debugging and troubleshooting, as developers can focus on specific components without needing to understand the entire codebase. While micro-frontends offer numerous benefits, they also present certain challenges that need to be carefully addressed. One notable challenge is the complexity of integration testing. Ensuring that independently developed components seamlessly integrate and work together as a cohesive unit can be demanding. Thorough integration testing is crucial to identify and resolve any compatibility issues between micro-frontends. Another challenge lies in maintaining a consistent user experience across all micro-frontends. With different teams potentially working on different parts of the application, it's essential to establish clear design guidelines and communication channels to maintain a unified look and feel. Inconsistency in design language can lead to a disjointed and confusing user experience. The deployment and management of micro-frontends can also introduce complexity. Deploying and managing multiple independent components requires robust tooling and infrastructure. Teams need to coordinate releases, manage dependencies, and ensure smooth communication between different parts of the application. Furthermore, there's a potential risk of technology sprawl if not managed carefully. While technology diversity can be advantageous, excessive fragmentation of the technology stack can lead to maintenance headaches and increased complexity. Establishing clear guidelines for technology choices and promoting code reuse across teams can help mitigate this risk. Micro-frontends are not a silver bullet for all web development projects. They are most beneficial in specific scenarios. Large and complex web applications with multiple teams working on different features or sections are prime candidates for a micro-front-end architecture. Breaking down such applications into smaller, manageable components can significantly improve development speed, scalability, and maintainability. If your application requires a high degree of flexibility and the ability to adopt new technologies quickly, micro-frontends can be a good fit. The ability to choose different technology stacks for different components allows teams to experiment with new tools and frameworks without impacting the entire application. However, for smaller applications with simpler requirements in a single team, a monolithic front-end architecture might be a more straightforward and manageable approach. The added complexity of managing multiple components and integrations might outweigh the benefits in such cases. In conclusion, micro-frontends offer a powerful approach to building scalable and maintainable web applications. By embracing modularity and team autonomy, they empower organizations to develop complex applications with greater agility and efficiency. However, it's crucial to carefully consider the challenges associated with integration, user experience consistency, and deployment complexity before fully adopting this architecture. If you enjoyed this video, don't forget to like, share, and subscribe.